Hello everyone. In this lecture, we'll be doing calculations for power and currents of amplitude modulated wave. So let us start our discussion with DSB-FC wave. We know that this type of transmission includes the carrier and both the sidebands. That is why its power equation will contain all the power components, right? That is due to your carrier plus power due to upper sideband plus power due to lower sideband. Okay. And we know the formula of power for cosine function, that is power equal to VRMS square over R, correct? So this expression will remain valid for all the three powers. So this can be rewritten as V, I'll represent this V carrier CARR square by R, alright, plus V USB square by R plus V LSB square by R. Now let us calculate individual parts and later we'll add all three parts. So let us consider for PC first. So this is V carrier square upon R. So V carrier can be written as VC over under root whole square, right, over R. This is actually the RMS value of the wave, and this can be further reduced to VC square over twice of R. So this is my power of carrier. Now let us calculate for upper sideband and lower sideband. They will be having same power. So I can write it in this way: PUSB equals PLSB equals V, let it be SB square, right? Instead of writing VSB or USB or LSB, I'll write SB, sideband square, okay, over R. So this can be further written as MVC by 2 divided by root 2 whole square over R. This value MVC by 2 actually is coming from this equation of AM wave, right? Here you can see the amplitude of sidebands. It is same for both the sidebands. So this can be further written as M square by 4 multiply VC square over 2R, correct? Now put all the values of power in this equation and we get full power, means total power, equals the power of carrier plus the power of sidebands. For upper sideband and for lower sideband it will be same. So I'll write same power in both the places by 4 VC square over 2R. Let us take this VC square common from all the three expressions. So what I get, VC square by 2R bracket 1 plus twice of M square by 4, and this will get cancelled out. So ultimately I get VC square by 2R multiply 1 plus M square by 2, okay. And we know this is the expression for carrier power, right? So this expression can be further, this equation can be further reduced to PC multiply 1 plus M square by 2, alright. So that is the expression for power of DSB-FC wave. Alright. Now let us do the calculations for current for this wave. So you know the general expression for power is I square R. In terms of current, if I represent it, so I'll use this expression, but before that let us rewrite this equation first. So this becomes PT over PC equals 1 plus M square by 2. Now let us make use of this expression. So your PT will become equal to IT full means total current multiply R, IT square multiply R over IC square multiply R equal to 1 plus M square by 2. Okay, from here you can see the R will get cancelled out and you are left with only this part. So the total current of AM wave comes out to be IT equals IC multiply under root of this whole thing 1 plus M square by 2. Okay, and this we have calculated for DSB-FC wave. Next is the calculations for DSB-SC AM waveform. In this expression you can see the carrier is being suppressed, only we are transmitting is the sidebands. That means your power, the significant power, is only consumed by the sidebands, and power consumption by carrier is negligible. So power expression for this particular scheme can be written as total power equals PLSB plus PUSB. Further, we can write it in form V RMS square by R. So this becomes V LSB square over R plus V USB square over R. And we know that power of LSB is exactly the same as power of USB. So this can be written as PLSB equals PUSB, and well, in place of LSB or USB, I'll write VSB square over R. Okay, so this becomes, this I'll replace with MVC by 2 over root 2 whole square divided by R. Okay, so ultimately we get M square 4 VC square by twice of R. Sorry, it is twice of R. Okay, now let us substitute this thing in this equation. So what we get, PT will become equal to, in place of this I'll write M square by 4 VC square over 2R. Likewise for VUSB square by R, for this expression I'll write the similar thing, M square by 4 VC square by 2R. And we know VC square by 2R is nothing but PC. Okay, so on reducing this expression further, we get PT equal to PC multiply M square by 2. Okay, so that is the expression for total power of DSB-SC waveform. Now I'll calculate for current for same waveform. For that purpose, let us rewrite this equation in form PT over PC equals M square by 2. Now we know that P in terms of current can be represented as I square R, right? So I'll use this expression in this place. So your equation becomes IT square R over IC square R equals M square by 2, correct? And RR will get cancel out. So we get IT equals IC M by root 2. So that is the expression for total current of DSB-SC waveform. Next we'll do the calculations for SSB-SC system. Now we know it can have two different equations based on the type of filter we are implementing. We can transmit either the upper side frequencies or we can transmit lower side frequencies, right? But condition is that one sideband to be transmitted only, and we know that the power of both the sidebands is same. So whatever sideband you transmit, the power will be same. That is, total power will be either power of LSB or it can be power of USB. This can be further written as equal to M VC by 2 under root 2 whole square divided by R. So this becomes total power equals M square by 4 VC square by 2R, or alternatively we can write PC M square by 4. So that is the expression for total power of SSB-SC waveform. Now current for this wave can be calculated in similar way. For that, let us rewrite this equation. PT over PC equals M square by 4, right? And we know power can be represented in terms of current, that is I square T, I'll write it I square T R by IC square R. Okay, and this is equal to M square by 4. So ultimately we get IT equals IC, this R will get cancelled out, IC M by 2. Okay, so that is the total current expression for SSB-SC wave. Next is for VSB-SC modulation, AM modulation. We know just like SSB, we can have two different equations based on the transmission type, or you can say the selection of band pass filter. If we are transmitting upper sideband, full upper sideband, then a vestige of lower sideband will be transmitted, and if we are transmitting lower sideband, full lower sideband, and in addition vestige of lower sideband will be transmitted. Whatever transmission we consider, the power will remain same. We can write this expression as total power of VSB equals vestige of one sideband, that is m square by 4 PC, plus full power consumption for another sideband, that is mc square by 4 multiply PC. So this is the total power for VSB-SC transmission. So that is all for this session. See you in next one. Thank you and have a nice day.